Mastering machine learning integration. Machine learning models are only as good as the KPIs that measure them. Where can we identify the key performance indicators, KPIs, that its implementation team uses to measure the success of its machine learning model integration into production? Identifying key performance indicators, KPIs, is crucial in measuring the success of machine learning model integration into production. The implementation team should focus on KPIs that provide insights into the model's performance, data quality, and business impact. Here are some essential KPIs to track. 1. Model performance metrics. Accuracy, the proportion of correctly classified instances out of total instances. Precision, the proportion of true positives among all positive predictions. Recall, the proportion of true positives among all actual positive instances. F1 score, the harmonic mean of precision and recall. Mean squared error, MSE, or mean absolute error, MAE, for regression problems, measuring the difference between predicted and actual values. ROC-AUC, the area under the receiver operating characteristic curve, indicating the model's ability to distinguish between positive and negative classes. Loss function, the objective function the model is optimized for, such as cross-entropy or log loss. 2. Data quality metrics. Data freshness, the time elapsed since the last data update or refresh. Data completeness, the proportion of rows or columns with missing values. Data consistency, the level of consistency in data formatting and encoding across different data sources. Data drift, the degree of change in data distribution over time, affecting the model's performance. 3. Business metrics. Revenue growth, the increase in revenue generated by the model's predictions or recommendations. Customer satisfaction, the level of satisfaction among customers interacting with the model-driven system. Conversion rate, the proportion of users completing a desired action, such as making a purchase or filling out a form. Return on investment, ROI, the return on investment for the machine learning project, considering development, deployment, and maintenance costs. Cost savings, the reduction in costs due to process automation or optimization enabled by the machine learning model. 4. Operational metrics. Model updates, the frequency and timely deployment of model updates, ensuring the model remains relevant and accurate. Model retraining, the frequency and efficiency of retraining the model on new data, allowing it to adapt to changing patterns. Inference time, the time taken to generate predictions, affecting the system's responsiveness and user experience. Memory and compute resources, the efficient use of computational resources, such as GPU, CPU, and memory, during inference and training. Uptime and downtime, the percentage of time the system is available and functioning correctly, and the time spent on maintenance or debugging. 5. Monitoring and alerting. Anomaly detection, the system's ability to identify unusual patterns or outliers in data, allowing for swift intervention. Error rates, the frequency and severity of errors, such as data manipulation errors or model inference errors. Security, the measures in place to prevent unauthorized access, data breaches, or model tampering. To effectively track these KPIs, the implementation team should 1. Establish a data warehouse or dashboard to centralize KPI tracking and visualization. 2. Define alerting mechanisms for anomalies, errors, or performance degradation. 3. Schedule regular review and analysis of KPIs to identify areas for improvement. 4. Implement version control and auditing for model updates, data changes, and system modifications. 5. Establish communication channels for stakeholders to report issues or request changes. 6. Continuously monitor and re-evaluate the relevance and effectiveness of the chosen KPIs, adapting to changing business needs and model performance. By focusing on these KPIs and implementing a robust monitoring and tracking system, the implementation team can ensure the successful integration of machine learning models into production, driving business value and operational excellence.